All right, now let's talk about some logic. I want to give you the first three laws as Aristotle, the first three rules of logical discourse given by Aristotle. So Aristotle was this kid. He died in 322 BCE. So sad, sad day. Rip. But he was a peripatetic philosopher, or more precisely, the philosophers who followed him around, his disciples, they called themselves peripatetic philosophers. Now, a peripatetic philosopher, what is that? Well, I mean, it primarily means someone who follows Plato around. Aristotle around. But I was at this, meeting at Harvard with a bunch of doctoral students and this other doctoral student there, and he was like, I'm studying philosophy. I was like, oh, what kind of philosophy do you? And he said, I'm a peripatetic philosopher. And I said, oh, really? You're a peripatetic philosopher? And he said, yeah. And I said, so you don't drive anywhere? Honestly, it's it's a funny joke. But peripatetic means people who walk around, right? So I said, you don't drive anywhere, and he just looked at me confused because even a peripatetic philosopher at Harvard didn't get my joke about peripatetic philosophers. Anyway, it was funny. All right, so peripatetic philosophy. Um, anyway, it doesn't even matter. We're not even studying peripatetic philosophy. I just really told you that he's a peripatetic philosopher so that I could make that joke again because it was so funny the first time. um, yeah. All right, logic. Why are we studying logic? Why do you need logic? Well, logic is first of all, logic is dope. I definitely think he's the best rapper around these days. But it's also just his positivity, right? It's yeah. Anyways, good stuff. Why do you need logic? Well, you need logic in order to be able to communicate clearly with the people that you want to communicate with, right? Whether you're talking about a legal document, you need to be able to read it logically and carefully. You also need to make big decisions in your life, especially once you get out of mommy and daddy's pocketbook. Then you'll need to make big decisions and take care of yourself. In order to do that, you'll need to make logical decisions, logical reasoning. In order to do that, you need to be able to think clearly and understand the basic rules of logic so that you don't get taken for a ride, basically. In the past, I've given this speech about big fish and little fish, and how you're basically either a big fish or you're get eaten. But So you need logic in order to take care of yourself and think independently from other people, not to be controlled, not to be just a pawn in somebody else's game. I mean, you're still probably going to be a pawn in somebody else's game. I know I am, but nevertheless, having logic at my disposal, being able to discern words clearly and carefully prevents me from being taken advantage of, you know, too often. Also, in order to do math, right? In order to math, numbers are things that we use in order to, if the reason math works is because numbers must be clearly defined, right? 5 always means 5. 5 plus 5 always means 10. 4 plus 20 equals, it's some 4 plus 20 equals 24, right? So different contexts and different contexts, things can symbolize or have differing meanings. But in order to proceed logically, we have to be clear and concise. We have to be clear and consistent so that our words always mean the same things. 4 always means 4, plus always means plus, 20 always means 20, and 24 always means tree emoji. Um, but the point is that in order to proceed logically, right? If we want to proceed mathematically, if we're going to do math, then we need to be able to take numbers and add them together, which means that the numbers have to be consistent in their definitions. 5 always means 5, 4 always means 4, 6 always means 6, right? We don't have varying. It depends on your perspective or something like that. No, 6 is 6, right? Plus is plus, divide is divide. And so likewise in philosophy, if we're going to use words and use equations and that sort of thing, using words, then our words need to be very clearly defined. Otherwise, we're just sort of adding lots of variables together, right? And as you know, in math, if you have too many variables, then you can't solve the equation, right? If I have a mathematical equation that's something like 4x plus y equals z, I can't solve that, right? I need more information. 4x plus y equals z just doesn't give me enough information, right? But if I have something like 4x plus 2 equals 10, oh, well then I've got plenty of information. I can say, well, x equals 2. X equals 2, right? But if I have too many variables, then I can't solve for x. Likewise, so some of you might be thinking, super smart people might be saying, but Doc, didn't you say that vague categories, isn't that the third step or some of the step? That second or whatever step of the phenomenological method, isn't it to identify the phenomenon vaguely and try to keep the category very vague? And didn't you say that Robert Neville and all that kind of stuff, like, don't give it too much definition? If you've already presumed to know what it is, then what's the point of doing the phenomenological investigation, right? So yeah, we have to keep that thing in the center of the circle unknown. We have to keep it variable, right? That's the whole point. We need to have some variable, otherwise why are we doing the equation? Why are we working through the logic? So we have to have whatever that thing that we're trying to figure out, you know, and soon it will be religion. Actually, sooner it will be is. Some of the sentences that come out of my mouth, it's like, wait, did he really say that? Yeah, so in a minute it will be is. All right, so yeah. That's true. So you've got to have whatever's at the center of that circle needs to be a vague category. But in order to get towards that variable, to have some sort of more understanding of what that thing is, everything else, the other words we use, we need to be logical. We need to use words carefully, clearly defining them, so that, because we can't have too many variables, right? So we want to try and clearly define this and this and this and this and right? So that this becomes the only unknown. This is part of what in scientific methods, you know, you would call having control, right? Control groups, control for this, control for that, bracket out everything. Let's make this certain, let's make that certain, let's make this certain, so that we can, when we find this unknown, it's that only one unknown in our equation, right? So that only one unknown, that's the thing we put at the center of our phenomenological circle. Everything else we want to try and have defined as clearly as we can, right? So when we're using words like soul or spirit or those kind of things, those are kind of words that we can clearly define and have a clear understanding of what we mean by those words when we use them. But then some other words that, you know, we're going to need to allow to be very capacious and free and vague and, right? Words like God and scripture. All right. So all that's why we need logic. But what is logic? What are these rules of logic that I'm trying to teach you? Well, according to Aristotle, there were 3 of them. To Aristotle gave these 3 rules of logic. The first one is usually known as the law of identity, then the law of non-contradiction, and then finally, excluded middle. I've actually already taught you all of these in the previous unit. We're talking about 0, but I will teach them to you again, this time more explicitly. So, law of identity is basically definitions. Let's be clear about our definitions and explicit about our definitions, and a definition should make things finite, right? Let's clearly define the boundaries, the finitude, the finish line, the boundaries of whatever it is that we're trying to discuss. So whatever it is, let's call it A, right? Let's clearly define A so that anything inside of this description, this definition, everything, we've made A finite by saying here is, everything in here is A, and everything outside of here is not A, right? Anything that's in here is A. Anything that's not out, anything that's outside of that is not A, right? So earlier we gave the definition of a circle. A circle is an infinite series of dimensionless points equidistant from a single dimensionless point, and anything outside of that is what? Not a circle, right? Are there some things that are both a circle but not a circle, or are neither a circle nor a not circle? No. So this is the third law of logic is excluded middle. So we should have, even though I'm drawing this boundary, and maybe you could have like an A not A like scribbled on top of the line or something like that. That's kind of like overlapping. Aristotle said, no, that's not logical. In order to be logical, we have to have clear, concise terms that are clear, right? That say anything inside of here is that, and anything outside of that is not that. That's literally the law. So the law of identity is clearly define it. Law of non-contradiction says nothing can be both A and not A at the same time in the same way, right? So it could be like raining or not raining. Now it could be raining over there, and it could be raining here but not raining over there, but it can't be raining and not raining at the same time in the same way in this place, right? I'm not sure that raining is a good example, but that's just one that people use a lot. And it can't be both raining and not raining at the same time, so excluded middle. Let's make it a little less abstract. Let's make things a little bit more concrete. All right, now let's take an example. In the classroom, I usually try to think of an example like randomly off the top of my head, something that like, what should we define? What can we define? And then I always inevitably say red. Let's talk about red. And everybody's like, oh yeah, red. Okay, so let's talk about red. What is red? What's the definition of red? How would we define red? What are some of the ways that we can come up with definitions of red? What do we think about when we think of red? Well, in the past, I've had students mention all sorts of things. When they think of red, they think of, well, red means stop, danger, anger, warmth. What about a little bit more scientifically? What if we talk about pigment? So pigment, like from one perspective, we might talk about this piece of chalk that I'm using right now and say, oh, well, this chalk is red. It's red, isn't it? Well, depends on what we mean, right? That's why we're trying to clarify your definition of what red is, because an optics professor might say, well, if actually the chalk is every color except red. In fact, it's clearly rejecting red. It's absorbing every color of light except for red, and the red is what it's rejecting. It's casting out, right? So we see red reflecting to our eyes. We see red light when we look at this piece of chalk, because this piece of chalk is not red, but is absorbing every color of the spectrum except red, and then casting that red back to our eyes. So what do we mean by red? Do we mean red pigment, or do we mean red light? Recognizing that those two things are quite opposite, right? So then we could also mean light. So if we want to proceed logically, and we're talking about red, if we're going to use red in logical discourse, then we could mean any of these things. Fine, right? We can make red mean any of these things. But if we're going to proceed logically, we have to be clear about what meaning we are giving to red, and make sure that the people that we are speaking to have the same understanding, at least accept our stipulative definition of what red is and say, within the context of this conversation, I'm using red in this way, right? Let's not make it vague or unclear in any way, but let's give it a clear definition. So how about if we were to define it in terms of light? Then what clear definition of red might we give? Well, we might say, well, all right, so what if we define light, red as light particular spectrum of light, and that particular spectrum of light has wavelengths between 625 and 720 nanometers, right? So light functions as a wave. As we know, it also functions as a particle, but that's not this discussion right now. So red is light with of which the wavelength from peak to peak or trough to trough is either somewhere between 625 nanometers at a minimum and at a maximum 720 nanometers. And anything that's outside of that is not red, right? So we've got a clear definition of what, right? Any light whose wavelength is between 625 and 720 nanometers, that light we shall call red. Anything outside of those boundaries, anything that's beyond the finitude of those boundaries, it's not red, right? So red, not red. Now, logically, then, we've got law of identity. First rule, let's clearly define it. This is what red is. Nothing inside of here. No light. There is no such thing as light whose wavelength is between 625 and 720. That is not red. If its wavelength is between that, it's red. Period. That's it. If it's not that, it's not red, right? It can't be 624.999. It's not red, right? It's 720.0000001, not red, right? Excluded middle. Anything beyond that, higher than that, or lower than that, it's either infrared or it's orange, right? So red, not red. And nothing in between. Nothing is both red and not red. Now you could say, sure, like my hands are both red and not red because I have red chalk on them. But again, right, not in the same way. My hand isn't actually red. I just have red chalk on it. So, now one quick point. I'm going to come back to this again later, but I'm also going to go back. So, there's a point I've mentioned before, which I'm going to mention again later, and I'm going to mention it again right now, which is that the definition of a circle is an infinite series of dimensionless points equidistant from a single dimensionless point. Now, Aristotle here said, first rule of logic, clearly defined. Second rule of logic, anything that's not that is not that. And then the third rule is that nothing can be both that and not that. It can never be A and not A. It can never be red and not red. It either is red or it's not red. That's logical, right? If you're going to clearly define your terms, then you either say, yes, it either fits this definition or it doesn't fit this definition. So excluded middle. Now remember, our definition of circle is this infinite series of dimensionless points, right? So what do you call it? What's the thickness of this circle, right? How thick between... I now switch colors. How thick is the circle or the boundary between red and not red? Well, if we're going to speak logically, mathematically, scientifically, carefully, and all of those things which we are phenomenologically, then we need to say, well, there is no boundary between, there is no overlap, there is no, right? If there's an overlap, then we're not being clear about our terms, right? Or what we're trying to discuss is beyond the limitations of logic, which plenty of things in this course will be beyond the limits of logic, but we need to understand what the limits of logic are in order to be able to safely say, well, this is beyond the limits of logic, and then be able to explain why it's beyond the limits of logic. So the boundary between red and not red is dimensionless. There is no space between it, right? So a circle is an infinite series of dimensionless points, equidistant from a single dimensionless a point without dimension. Dimension meaning length, width, height, depth, right? It has none of those dimensions. It doesn't have width, it doesn't have length, it doesn't have depth, it doesn't have height. It has no dimensions. So this circle here, clearly this circle that I've drawn has dimensions, so it's not a circle. Let's get to that in a second. We'll come back to that.